All right, welcome back. We are COMP397 in the winter 2020 semester at Centennial, and we're week 8, part 3 of our broadcast. We just talked about adding a cloud, and I didn't put it up on GitHub. I was supposed to, but I didn't, but here we'll do it. So we'll add these to the staging area. We'll say added clouds to play scene, right? And we'll push. All right, so we want to talk about collision detection. How does this work? Well, best thing to do is to illustrate it a little bit. So let's pull up a couple of things. I'll pull up a drawing program, and let's talk about it a little bit again. So again, let's suppose I have my ocean. Here's my ocean. And let's make it so that it is locked up. And I'm also going to look at a cloud. And I also want to have a plane. And we'll even get an island. Okay, so those are things. Let's bring our island into where the ocean is. There it is. And let's get our cloud and bring that in there too. There's our cloud, and we'll get our plane, and we'll bring that in there. Okay, so some objects to play with. Get rid of these things. We don't care about them anymore. Okay, and we'll just we'll zoom in. So here's our cloud. Let's make this, just to make it realistic, 50% transparent. So there you can see that that's transparent, and we'll kind of come in there, and we can see that when I want to try and collide, there's a couple ways we can collide. We can use something called AABB collision detection, which we talked about before, which is like axis aligned bounding box. So it's axis aligned because this axis, which is the y-axis, and this axis are the same. They're on the same plane. They're on the same axis, right? They're axis aligned. They're pointing in the same direction. Same thing with the x-axis and the x-axis, pointing in the same direction. And what we want to do is, if we take the bounding area and we put it kind of overlap this, you can see that there's clearly an overlap between this image and this image. And for the most part, unless we get very close, right, you can see that there's no visual collision here. They're not colliding, but actually, logically they are. Why? Because there's overlap between one object and the other. So although AABB is a very simple collision detection algorithm, because you're just checking the top left corner of each object, and with the width, and the bottom left corner and the height, top left corner width, bottom left corner width, right, kind of stuff. You're just doing that kind of thing. You're going from top left to bottom right, and you're doing that. You're saying, hey, is this object inside of this object? If there is an overlap, we have a collision. But in here, there's a problem because we're making boxes, and this object is not really a box, right? You have some areas that are concave, and you have some areas that are convex, right? And it's not uniform. If it was a square, it'd be okay, but these aren't squares. So sometimes what we want to do, and by the way, it's especially noticeable when it comes to this. So if I bring the cloud in play, and then let me zoom with my plane, you can see that here clearly there's no visual collision, but there is a logical collision, and it's pretty long. Like, you can be, look, that's still a collision, right? That's pretty bad. Like, you're looking like you're not going to collide, but you're actually colliding, right? Player would get mad at this. They would go, hey, what's going on? How come I'm colliding? I'm not supposed to collide, right? So other options. You could, for especially objects like this small, you could wrap them in some kind of circle. So you could say something like, okay, let's make a circle, an ellipse, and we'll make it the same size as my island. Let's just say we'll make it so that it is transparent, and we'll make it yellow. And we'll bound it together. So we'll say this one and this one are just grouped. And the same thing goes here. We'll take another ellipse, top left corner, and we will just make it so that it is, I'm using an ellipse because you can have a different width and height. Let's just say this is the object. So ellipses or ellipses are pretty good. Again, you can group them together, and you can see that this is an ellipse. This is the bounding area. And you can even do that with this big thing too. Right? So do the same thing with this. So we'll get an ellipse, approximately the left-hand side of the screen, and we'll kind of put this over here like this, as best as possible, okay? And we'll bond these together. So this one and this one. It's not perfect, but who cares? All right, so yeah, now there's some optimizations. You can see that, you know what? The way the ellipses work, or the circle detection works is this. You can see that I have a half of my height. If I take this half height, which is from here to here, let's just say, and I add it to the half height from the middle to here, right? There's a half heights. I add these two lines together, and if it's less, when I add these two things together, then the distance between centers, it's less than this line. Collision, because now you're overlapping the circles, right? Overlapping the ellipses. And so that's how it works, right? However, you need to do two things. You need to find the distance between the centers, which normally we use square root, very expensive, or you can use squared radius, right? So we square everything, and so then we have a relative number, and if it's less than that relative squared radius, you still have a collision. Okay, that's how it works. Where it becomes a little bit better than this is where I'm moving this next to the cloud, right? The cloud before had more problems. Now the only thing is if it would be bad here because we have this concave area here and even here, but it's going to move so fast that I'm already in its kind of umbra that I'm going to get hit. It's going to be so quick. It's not going. You're not going to be able to tell, right? Where it's really bad is if I was going to move my plane from this side. If I move my plane from this side, then I would get hit. I'd be fully inside of the cloud, but actually there's no visual collision. And there's nothing much you can do about this. Truly, not much. However, there are, using this collision detection scheme. However, what you could do is you could divide this cloud into pieces, right? Where it's easier for you to do collision detection. Leave this the way it is, and then you could subdivide this cloud. Let's just ungroup, and let's get rid of this. So it's not a circle anymore. Maybe what you have is different shapes. For example, I could use a combination of rectangles. I can say there's a rectangle here. That's pretty good. And maybe, you know, there's another big rectangle from here to here. That's pretty good. And there's another rectangle from here to here. So we have a polygon with many rectangles. Let's say it's not as bad anymore. I'm being rough, really rough. So rough that it's wrong. Let's say it's something like this. And maybe there's another one. Maybe make smaller ones. You can subdivide this thing so it's not so bad. But now I want you to think about how this can be done. What can you do here? I mean, it's better. This represents things. But now what's happening? Well, I still got to do collision detection between each of these rectangles. And I'm going to do 1, 2, 3, 4, 5, 6 different collision detection for one object, right, at the same time. 6 times. So when I look at an object and say, does it collide here, 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 here? Where does it collide? I mean, it's a thing. It can happen, right? If I only have 4 clouds or 3 clouds and I have 5 or 6 different areas that can collide with each cloud, still you're looking at 30 different collision detections. It's very small. It's still more accurate if you want to be super accurate compared to what half width and half height is, or AABB. But I don't think you're going to get a better player experience using this. So that's one thing you could do, right? You can subdivide it. You can add other things too. You can use circles, different size circles too. right? So if circles suit you more, right, you can definitely use circles instead. So you can say, okay, I want a circle here, right, that encompasses it, you know, this area a little bit better, because that's more of a circular area, and you see that this is more circular, so maybe this is going to make more sense to be circular, right? Because I can kind of make a circle or an ellipse, a bunch of ellipses. Hell, you can even make them overlap. You can, if you want to, you can do one of these, right? If you can draw the shape so that it's a group of circles, right? And I don't know, there's like 5 circles there, and that's okay too, if you really want to. Okay, so multiple shapes, again, multiple collision detection, not a great result in terms of computational inexpensiveness, if you will, expense. The other option, what you could do is there's other collision detection schemes where you detect line-line collision. So you can basically draw these lines. This is exactly what you would do. You draw all these lines, right? And the lines would follow this object like this, almost like a polygon, right? And now this is way more accurate, but now I want you to see something here. Right, so let's suppose I did this. And again, these are just straight lines. They're not wholly accurate. They're not rounded like the actual shape, but it's much better, right? However, how many lines do I have? For every line that I have to do line, circle, line, square. Every one of those lines, right? And that's pretty crazy. Okay, it's pretty crazy. So this is more like a mesh type collision where I'm making a bunch of different objects. Or what I can do is when I make this object, I can create like these triangles. So I can make different triangles here. So I can say there's a triangle there and there's a triangle here, right? That's what I'm really doing. I'm making these triangles, right? And let's just say something like it looks like this. Maybe here like this, right? So I'm drawing different triangles here. And what I'm trying to do is create a mesh-like area where this is a collision mesh as opposed to a, you know, so you have all these rectangles and you're doing rectangle collision detection. Oh, sorry, triangles. You're using triangles to detect the collision detection area, right? And again, I'm just drawing this rough, but this is kind of what a mesh, 2D mesh does. Mesh collider, right? And the way it would work is you calculate each of these areas here as triangles, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different triangles, and those triangles kind of float together, you know, with the object, and then you would draw these objects. You would kind of calculate these triangles based on extents. So I would draw the object, find the extents on different areas. Extents mean how wide, how tall, different parts, right? Different angles. And once I find these extents, make some basic points, calculate some basic points, then draw triangles together with those points to create a polygon mesh like this. Okay? So it's possible. The calculation of the collider will take time to do. You do it once when you make the object, right? However, where it's really computationally expensive is every frame you got to check to see if any one of these areas here are colliding with other objects. So more accurate, way more accurate, right? Still not as bad as pixel perfect collision. Like I know exactly where this is happening. Nah, it's not that accurate, but it's accurate enough where it's really playable. And Unity, the Unity game engine and other game engines use this kind of thing. It's also an option. But this is like if you need a lot of detail. All right. So what are we going to do for us? I'm going to use circle detection because it's easy, right? If I had squarish objects, for example, if it was only this and this, my island and my plane, okay, AABB type collision, no problem. In fact, you can use different types of collision detection together. I can say circle when it comes to plane and my cloud, and AABB when it comes to my island and my plane. Okay? Let me show you. So I've already built up, and we've done this before, we've built up a collision manager. Let me just close all these things. Under managers, we have a collision manager, right? My collision manager has just some public static functions, a squared radius check, and there's also an AABB check. This is the AABB check function, okay? One thing we need to know is when we use these two functions, which object are we colliding with, right? So we can detect the object based on type. I can say, is this object instance of cloud? Is this object instance of island? And if it is, then collision with island, collision with cloud. Could do that. Or, because we have the ability to do this, we could simply just name them. So we could say the cloud in the start function, we can say that, because every object in CreateJS has a name property, this dot name. We can say that this dot name is cloud, lowercase c. And you know what? We can say that island, this dot island in the start function, this dot name is equal to island, right? And the same thing goes with my plane. Sure, I don't know if I would need that right now, but maybe in the future when I fire bullets at the plane, I would want to say that this dot name is equal to plane. Okay, so 3 objects, 3 names. And now that I have the name of the object, right? So I have the name of the object. Then in my collision manager, what I can do here is I can say this. I can say, let's do a switch case where, and this I'm just looking at the square radius check first. Switch on object2.name, object2.name. Case if the name is island, and so on. However, where this can be a problem, and I can do this work, it might be better to create game object type. Okay, game object type instead of the name. Why? I can use enumerations. I won't make a mistake the way I type my enumerations. Here I can make a mistake and I can beat my head trying to figure out what the problem is. But I mistyped the name. And that's a problem, right? An enumeration is much better in terms of safety, type safety. So let's do that. So let's make an object enumeration, or an enum. I'm going to make a new folder. Again, I'm doing this slightly differently than the first section. New folder. We're going to call this enums. Right? Here's our enums folder. And these are like utility or helper functions. Right? Make a new file. We're going to call this game object type. Game object type. .ts. This will be inside the module enums, the enums module. I'm going to export this enum, right, which is going to be called game object type. Okay, and there's going to be 2 enums, or 3 of them right now. We're going to have plane, island, and as well as cloud. Right? Maybe we'll do one more, number of types. So if we want to know the number of types, I can hover over here and I can see that there's 3 types, right? 0, 1, 2, 3. 3 number of types. So if I did this, then what I could do instead is in my GameObject superclass. By the way, first, because we added a new file, always going to my index.html. First, before I do anything else, before I make a game object, I'll make a game object type. So script, source. Enums. I don't know why it's not pulling up. Scripts, enums. Did I make it in the wrong place? Did I? Oh, wait. That's not good. Let's move that whole folder into scripts. Yes, move. Let's try that again. Thank God we did this. Game object type .ts.js. That's what we want, right? So there's our enums. Okay, and inside of my game object superclass, right? What we want is a game object type, right? So I want to make a property. So I'll say prop, right? And I want to call it the value underscore, actually let's undo the change, prop. I'll make the value, we'll call it type, right? That's what it is. And then the type will be enums dot game object type. That's the type. Okay. I'll take this part and I'll put it here. The game object type. So all game objects have it, not just one thing. All game objects. Okay. And these are getters and setters. I can put these getters and setters where they belong. These are properties. And I'll put them way down here. Okay, so type. And you know what? Just because I'm feeling weird about it, buttons should be a type. Label, because that's also is that a game object? No. Button is definitely a type. Ocean is the type. Game object, right? Those kind of things are important to be typed. So let's put them in the enums as well. So game object type, plane, island, cloud, right? Ocean, button, player. I mean, because that's a thing. We added that in there, right? So I think we covered everything. Scene is not a game object, right? No, it's a container. And vector2 is something else. Okay, so yeah, so that's what it would be. And then in my game object superclass, so let's just save this. In my game object superclass, then what I would do is when I instantiate stuff in my initialization, when I initialize all this stuff, right? What I also want to do is I want to set up type, right, by default. So what is the default type? And maybe by default it's none, right? So that's something else I can add in, a none type, no type of game object, or undefined. I can make an undefined type. Let's do that. So undefined. It's important for us to do this because that way, worst case scenario, it's something else, right? And it'll also remind us that we missed something. If we miss something, I say, hey, it's undefined. Okay, so by default, if I don't do anything, if in my constructor function, I'm going to set that the type is undefined. So I'll say that this dot type is equal to undefined. Objects dot enums dot game object dot undefined. That's what it's going to be. Okay, so that's what the type is by default. And this is good. This is undefined, right? Okay, cool. And then when I go back to my managers, or actually, let's go to my objects. So button in my start function, I'm just fixing all this stuff up. Instead of the name being a button, remember, because I'm kind of judging it on name, I can say that the type, this dot type, is equal to undefined, right? That's what I want to do. So I want to do that it's enums dot game object type dot undefined, right? Or button, which is what it should be. And why? Did I spell it wrong? What did I do? Enums. 3 buttons. Yay. 3 T's. Okay. Well, see, that's where we're doing a check. So this is what this is. Let's just copy this line and cloud. So instead of the cloud having a name, the cloud will have a type, and it'll be cloud, right? Go through the other ones. Island, right? So island will have a type. And this is a better way of checking than making mistakes. I can make a mistake, right? Like if I go through this, there's a very possibility that I might just mistype it, right? This way I can pick the right one, and it is something that I don't have to worry about after it's been done. So this is plain, and I'm not going to use this player. The player is almost like a test. That's what this thing is. So this will be player. And I think I got them all. Okay. So then, instead of checking object.name, I can check object2.type. And then I can say, well, in case it is a island, right? If it's an island, then do something. And it would be enums.gameObjectType.island. It's very explicit. But you know what it says. It's the game object type is an island, right? That's what it is. Or what about if it is enums gameObjectType.cloud? Okay, so that's the two options that we have. So island or cloud. If it's an island, let's do a console log that says collision with island. And if it's a cloud, we'll say collision with cloud. And we'll do the exact same switch case here. For now, we'll do it with AABB type collision detection up here. So depending on the type, we'll switch it and we'll say, we can use either one. Okay? Great. Now we need to use these things and check to see if they're good. And the way to use them is if I go to my play scene, let's just close some of this off. Let's make sure that everything is saved first. So save all, close everything, go to my play scene. This is a bit of an overhaul. We did a bit of an overhaul because we changed something in the GameObject superclass. And once we do that, then we change lots of stuff, potentially. So under scenes, I'm going to go to my plane.ts scene. And in my update now, I want to do two things. So after my plane and my update are plane and island update are happened, then I want to do this. I want to say managers.collision. And we'll say between the plane and the island, we'll use AABB check. AABB check between my plane and my island. Okay, so just a regular AABB check. And then from my cloud, we won't do an AABB check. We'll do the squared radius check. Okay, so we'll say that we'll update the cloud's position, and we'll say managers.collision.squared radius check between this._plane and the cloud, which is this cloud. And that should do it. Let's see if it works, right? Okay. So back to this. Let's see if we go to here and we have our little game in the local host and start. And let's pull up our little collision detection area here, a little console, and we're seeing if we get some collisions. Collision with cloud, collision with cloud, collision with island, collision with island, collision with cloud, 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 island, cloud, island, cloud. There's my island. Oh, missed my island. There's my island. Cloud, island. See? Works nice. That's how you do it. Okay, so now we're using two different types of collision detection. If you go back, two different types of collision detection. AABB between plane and island, and circle square radius check between cloud and plane, right? Why? Because it makes more sense, right? Otherwise, you'll have these edges, and there's a lot of edges on the cloud, and it's better to have some kind of radius between the two. In this case. All right, now let's put this up. So we put this up on GitHub. We'll say that we implemented simple collision detection for placing. It's a really long update, and you can see that it tells you that 3 characters over 50 character limit, which is totally fine. I would accept that. Let's add these all to the staging area, and then I'll click this commit, and then I'll push it. Okay, so that's going to be up online, and this is good. Now what I want to do is I want to say when I collide, I want to make some sound. Okay, so how do we do this? So first of all, sounds. We know we are using sound.js, right? So under my game.ts, we can preload sounds too, right? So let's do that. So we'll say that we'll load up 3 sounds. Okay, 1, 2, 3. The first sound is the engine sound of the player, and it'll be under assets audio, if I'm not wrong. Let's see. Assets audio, and we're going to make it engine.og. Engine.og. Right? And we'll do, for my next one, it'll be the yay sound. So it'll be assets audio yay.og. And then the last one is assets audio thunder. So we'll call this the thunder sound. Assets audio thunder.og. Oh. Thunder.og. Make sure everything's spelled properly. And I think we're good, right? So that preloads all of our sounds. So sounds are here, images are here. And you can see that our images are getting pretty big. Next week I want to talk about sprite sheets and how to combine all these images into one big sprite sheet, right? So we can load one sprite sheet and not use them all, and then talk about some animations we can do. All right, so cool, right? We've loaded them up, but I want to use sound.js. Notice that we've already enabled us to use sound to preload, and sound.js is kind of enabled already. So what can we do? So it preloads first, and once we preload everything, then what we want to do is, let's suppose when we instantiate my plane, when the plane comes into play, I want to make the plane sound, the engine sound of the plane. So I can do it in 2 places. I can do it with the plane, or I can do it with the scene. I think with the plane is probably better. So I'm going to go to the plane itself. So go to the plane.ts file. And when I start my plane on start, I declare a couple things. And then let's say at the bottom of this, let's play our engine sound. So I'm going to say sound.js. So create.js has sound, right? And what I can do is, just like sound.js is the thing that I want to use, right? So if you look at sound.js for a second, let's just go to the sound.js documentation. Sound.js, right? For it comes to playing sound, you can see how it's done. create.js.sound.on, create.js.sound.play is what we want to do, right? create.js.sound.play and whatever the sound is, okay? But where are we getting this sound? From the preloader. So this is how it's going to be. create.js.sound.play, and then the name of the, now notice these are all the options it has. String, interrupt, blah, 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 whatever. And there's also one thing that says loop, right? We're going to say loop is -1, which means it'll play forever. All right? So play the sound. So we're going to say that, okay, config.game.assets.getResults, and this, the friendly name for the sound is engine. So that's the sound name, right? So get result engine, right? That's what we want to do. Notice that we're getting a bit of an error. It's natural. It's normal, right? Because that is the name of the sound we want to play, right? Engine. And what I could do, because this is what I want to do, is if I just did this engine, the engine sound, right? that assumes that I know what that is that I'm playing, okay? But that's what I want to do. So let's see if this works. Now, what I want to do is also say something like this. I need to make a reference to this thing so I can turn it off and on and adjust the volume. So I can say let, we'll call this engine sound be equal to this for now, right? If you notice, engine sound is of type abstract sound instance. That's the type, right? And what I can do with this, I can say that engine sound dot, and I can do different things like loop is equal to -1. Loop is a number. It gives us a number between, it's how often do I want to loop, the number of loops, or if I put -1, it'll loop forever. I can also say that engine sound dot volume, I can set that to 0.5, so 50% volume, right? Oops. So, and I can try and also set those automatically. So this is loop forever. So it's going to keep playing this sound over and over again. Notice that engine sound is an object that only exists inside my start menu, and it'll be gone after I make it. Which means if I do this, and if I never want control over my sound again, that's okay. If I want control over my sound again, I need to make a getter and setter. It has to be a public property so I can turn off the sound and adjust the sound later on for my plane. Okay, I'm just letting you know. Those are the things we have to do. We may have to adjust this later. Right now, we're going to make it work. So let's see if this works. So save it. And then when we play our game, if everything goes well, when we start a game, we should hear a sound. And let's turn up the sound to see if we can hear it. Right? And let's see if we're going to get anything in the console, because that's an important thing. So there's my collision, but you can see now that I'm not getting any sounds, right? See that? No sounds. And it could be that I'm up on here or not, but I doubt it, because I'm hearing sounds locally. Unless you should really be hearing it, but you're not, because that is weird. Let's see if I can do that here instead. Alright, so yeah, so it's not playing any sound. And we're getting one error. Let's see what the errors are.
Maybe you have to add
No.
to the scene.
So it says, look. So it says HTTP localhost 3000 assets audio engine 404 not found. Oh, I spelled it wrong. Ha ha ha. See, when I talk about like loading stuff up? Yeah. I knew it was something dumb, because it totally should work. So let's go back to the preloader game.ts and make sure that it spells right. There we are. Yeah. Right? Alright, so that's the engine sound. It's still, in my opinion, way too loud. That's like, I mean, even though I'm 87%, it should be way, way lower than that. And you can adjust that in your plane. Because remember, we have that in the plane sound. Let's make this so it's like 0.1. Like at least 5 times quieter than that. So again, save. And let's just refresh this one. That's better. Okay, so now that I have this, let's do the same thing for my impulse sounds. Impulse sounds are sounds that are going to go off and then they're going to stop by themselves, right? Like an attack or a hit or something. And we have a couple of them. We have the yay sound and the thunder sound. So let's do that for the cloud. So when the cloud gets hit, what happens? And I'm going to do this time inside the collision manager. So in the collision manager, I'm going to do it twice. One for squared radius check and one for AABB check. So again, it's going to look like this. I'm going to say when it hits the island, create.js, .sound, .play, And then it's just going to be called the yay sound. And then when it hits the cloud, it's going to be this, and it's going to be the thunder sound. Okay, thunder sound, yay sound. And let's just put those back down here too, just because that way we can do the same thing. A little bit duplication, but we're trying to show different kinds of collision detection happening. And this is only one way of doing it, of course, many different ways. Okay, so we got this going. Let's try it. So, oh man, what's happening? How come my sounds aren't working? Did I not save? Let's refresh. Maybe it needs to be refreshed. Did it save? I didn't see it reload. That's the thing. So I wonder what happened here. Collision.ts, because I didn't see it save. But it does show the changes. It does show the changes. And how about online? Do I actually see the changes happening on my sources? I have my sounds. That's good. What about my script? Sorry, this is all troubleshooting stuff, guys. So managers, collision.ts. I see the sound. Isn't that interesting? But it won't play the sound. Why is that? Oh, I know why. I totally know why. No, it's because of this. Yay and thunder are spelled lowercase yay, and I told you it's all misspelling. It's where we, like, you know, you want to hit yourself in the head and say, this is like, no, it can't be like this, right? It's not so easy. It's not so dumb. It's dumb. It didn't even give me an error. It just said, okay, you're looking for something that doesn't exist, so well, too bad. All right, let's try it again. Now that's interesting, because that should totally work. Okay. Did I save it? Thunder and yay. Great just on play, yeah. Oh, that's interesting.
Yay. Yay.
Too loud. Right, way too loud. So, like I said, it needed a reboot. So again, just like we've done here, I would make a sound, like I would say, like let yay sound equal to this, right? And then what we want to do is just like before, would say yay sound dot volume is equal to 0.1. I would recommend that. Turn the volume way down. If you don't like that, or if it's too low, like maybe it's even 0.2, because this impulse sounds is okay, right? And this will be the thunder sound. So let thunder sound equal to this, and we can just do something that looks like this. Thunder sound dot volume is 0.2, and I would do the same thing down there. So kind of copy paste. So that way we can just modify the code that we have just to make it a little bit more reasonable when it comes to this kind of stuff. Again, it just takes a little bit of a reboot. Make sure that things have transpiled, which looks like they have. And we'll rerun this thing and then see how it works.
Yay.
Let's run it again, like I said, and it shouldn't be that loud.
Yay.
That's better.
Yay. 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 Yay.
He's very excited. Right?
Yay. 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 Yay.
Ow.
Yay.
Right, you can see it's pretty good. You can also tell that the game, I mean, I was able to play that game with only half a screen, and I'm pretty good. Not because I'm that great, but because it's a little bit too easy at this level. So if you really wanted to, you can always up this number to 4, right? So that's from a cloud perspective. Let's add 4 clouds instead of 3 clouds. And again, it seems to be my light server is not really doing its job, because it's not, see how it's not, when I save this, it doesn't do anything here? That is an issue for me. So let us go to this, and we'll control C this and light dash server. Sometimes we lose a connection, which I'm not happy about, but it's because I got a lot of stuff going on.
Yay. Yay. Yay.
Yeah, there's 4 clouds now. Right?
Yay.
It's rare to see them all on the screen at the same time because of the offset, right?
Yay.
Because what's happening, some clouds
Yay.
start higher than other ones, but now it's like, it can be
Yay.
very dangerous.
Yay. 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 Yay.
Okay. Okay. How about this? The other thing I noticed here when we're just optimizing, and it's the last change I'll do for today, is wouldn't it be nice if our clouds were slightly bigger or smaller sometimes? Guys, be careful with this. Even though we make our stuff bigger and smaller and I change the scale of something, does not mean that my when I change my scale that things change. So remember that in my GameObject superclass, I just want to talk about this first. I'm not going to do it today. Maybe we'll talk about it next week if you remind me. But if I go to my objects and if I go to GameObject.ts, is there a way to set scale or anything like that? I mean, I can do width and height, right? Half width and half height, position and velocity, but there really isn't any scale setting. And let me talk about this first. 1, if I set the scale, do the bounds change automatically? Does my width and height change? If my width and height doesn't change, then when I reset the scale, remember my positioning, my reg-X and reg-Y, registration points for X and Y also have to change. There's a lot of changes that have to be made here for me to set the scale. When I monkey with the scale, like on the X-axis or the Y-axis, it offsets the point in the middle to something else. And on top of that, it could. On top of that, the boundaries, the borders for my collision detection would also change because it's based on width, right? Top left corner, width, and so on. And unfortunately, those have to change automatically too. So I need another function called get scale and set scale. And get scale and set scale would then modify the scale X and scale Y values of the texture itself, the actual bitmap, in the background, but then also change the width and height values and the reg-X and reg-Y values of everything. So set scale is actually quite a complex, or there's more things going on when I do set scale, right? Just letting you know. Right, so there's a lot of stuff in there when we set the scale. Same thing with rotation. If I rotate an object to the right, does it change the width and the height? No. Doesn't. So actually what I'm doing when I rotate, if I ever did rotations, and let's just go in here and we'll delete some stuff. So let's suppose I want to get rid of all this. I made some nice drawings here, but these are all useless for now. So I don't care about my plane. But let's suppose, actually I'm going to do that. I do care about the plane. I want to ungroup for a second. And let's suppose, I'll get rid of all this. Let's suppose that the plane has a bounding box, and I'll leave you guys with this thought and see if you guys can think about something to do. A bounding area, which is a rectangle, okay? So here's my bounding area. Okay, cool. I don't care about the shadow. Let's say I don't care. If I rotate the bounding box, if I rotate the ship, the bounding box doesn't rotate. The only thing that rotates when I rotate this is the texture. So it does this, right? That's what it does. But my bounding area doesn't rotate. See, the wing is outside the bounding area. So this would be bad. This would be really bad for me to do, right? In fact, rotations are one of the most difficult things to calculate when we want to reskin our collider, right? So for example, here, whenever we rotate, now we got to recalculate the bounds. Because the bounds aren't that anymore. It's this other bounding area here. You see that it's already done it for us. The bounding area changes according to the texture, because it still has to be drawn somehow, right? So the texture is going to be like this. That's the new bounding area. You see? The bounding area has changed now, right? It goes back to extents. What is the rightmost pixel? What is the leftmost pixel? What is the top? What is the bottom? And if I change at a certain degree, let's say, for example, 1 degree, 2 degrees, 3 degrees, 4 degrees, right? I'm going to have a lot of variation in terms of my height and my width. The way I'm doing height and width right now is based on the boundaries of my object. There's boundaries of my object, and then Create.js helps us because there's actually another function called get transform bounds. So there's get bounds, and I'm just going to point this out to you. There's also this dot get. And notice if I say transformed bounds, I can go with width and height and whatever, because bounds is the size of my texture. Transform bounds does all those calculations for me, right? So that's something else that I also have to think about. When we transform the object, what is the transform bounds? X and Y and so on, okay? Just letting you know. Okay, so there's things we can do to make scaling happening. It's not as easy as you think. If you're thinking about scaling your object up or down with code, as opposed to doing it by changing your object, there's more involved. Okay, we'll talk about that next week. Okay. So I'm going to leave you with this thought. We're at the end today. So a couple things to note. One, what did we cover today? We covered the assignment stuff. We talked about it in video 1. And the second thing we covered was how to add overloaded functions and constructors. We show the constructor function, how to do that. Then we added an island and a cloud object. We talked about cloud pools. We made a cloud pool or an object pool of a type, where we had an array of clouds that we updated all at the same time. We did that. We talked about simple collision detection, no response. There's not a response to collision detection, just collision detection. We can detect collisions. And making simple sounds, both sounds that are in the background. So for example, for your soundtrack, that thing that I did that lasts forever, that loop, is like a soundtrack. It'll keep going over and over and over. Be careful when you use MP3 files. They're very, very large. They can add megabytes to your project, and it can really be computationally expensive and long time to load when it comes to your preloading, because it'll wait for everything to preload first before your stuff opens up. So if you have lots of little soundtracks for that particular scene, it'll take some time to load. So we talked about that, and impulse sounds, little sounds that happen by being hit or running over an island or whatever. And those are the sounds we talked about. So we talked about a bunch of stuff. When we get together next week, again, we want to finish this off. We're still missing score and lives, how to do those kind of things. And any other special effects. I definitely want to add in a sprite sheet, how to do sprite sheets, how to deal with those, right? I don't want to just have individual objects. I want to have sprite sheets that I can use so that I can access them. Remember, sprite sheets are like texture atlases. That's what they're like. I look at a particular sprite sheet and I say, I want to look from this point to this point, and that's one of my textures. And here's another one, and here's another one. And they're all on the same sheet. Why? Loading up a sprite sheet is cheaper from a operating system file load perspective than loading individual files, number one, okay? So there's advantages to doing that, okay? And also from a animation perspective, I want to go from one point on the sprite sheet to the other, and I don't want to load up 10 files for one animation, just one sprite sheet. I load everything up, and then I just move from one place to the other. I show different things, okay? So that's what's happening next week. Any questions before we go? Remember that two things, actually. Alpha is due tomorrow night, and your peer review, your third peer review is due tomorrow night as well, okay? All right, that's it for me, guys. I will see you next Saturday, and we'll continue from there. I'll put this up on GitHub too.